What if you were given the second derivative of a function and someone wanted the original function? Well, if they give you some points either on the first derivative or on the original function, you can figure out what that is. So what we're going to do is take the antiderivative or integrate, and it's with respect to x. All of our variables are x's. So if the second derivative of function f at x is 12x squared plus 6x minus 4, then I know that the first derivative, I'm going to integrate one time, okay, will be the following. So I raise the power by 1, so it's x cubed. I'm going to divide by my new power, so divide by 3, and that gives me 4x cubed. Raise the power of this 6 plus 1, so it's 1 plus 1 is 2, so I'm going to have an x squared. Divide my 6 by the new power, a 2, so I have plus 3x squared. And then here's my constant term, which means you could say you have an x to the 0 power. Raise the power by 1, that makes it an x to the first. Divide my coefficient by the 1, so it's minus 4x, and then I'm going to put a plus c. And keep in mind this is a constant term, so we know the antiderivative had to have been linear. Okay, well, it would be nice if they'd given me a point on the derivative so I could figure out c, but they didn't. What they gave me was 2 points on the original function, so I'm going to have to take the antiderivative again. So I'm going to say my original function is going to be equal to, and I'm going to raise the power again, so x to the 4th, divide by my 4, so I have 4 over 4, it's 1. Then I do it again, so plus raise the power x cubed, divide by 3 here will be 1 again, and then when I add 1 to this power it becomes an x squared. When I divide this negative 4 by 2 I get minus 2x squared plus, well, this is a constant, so it's got an x to the 0 sitting next to it. Raise the power, and I'm going to get a plus cx to the first, divide by my 1. The problem is I have to put another c on, so what I'm going to have to do is make this a c sub 1 plus c sub 2, or you could use another letter. Well, I need to figure out what this function is. I've used this function. I've done as much as I can. What I'm going to do is actually use these 2 points to solve for my c's. So I'm going to plug this one in first. So f of 0 equals 4. So 4 will equal 0 plus 0 minus 0 plus, and if you look at this, c sub 1 times my 0 is still another 0 plus c sub 2, which worked out really nicely. So I know that c sub 2 equals 4. So I'm going to rewrite my function, and I'm going to say f of x equals x to the 4th plus x to the 3rd minus 2x squared plus my c sub 1x plus 4. So now I go to my second point. I'm going to plug in 1 for x and 1 for y for f of x. So 1 equals 1 to the 4th is 1, plus 1 to the 3rd is another 1. 1 squared is 1 times negative 2 is negative 2, plus 1 times c sub 1 is just c sub 1 plus 4. So I have 1 equals, and I can add this up, 1 plus 1 is 2, minus 2 is 0, plus 4 is 4, so 4 plus c sub 1. That implies that c sub 1 equals 1 minus 4, or negative 3. At that point I can write my original function in. I've got every piece of it. So I have f of x equals x to the 4th plus x to the 3rd minus 2x squared. My c sub 1 is negative 3, so minus 3x plus 4. And with enough information, I can get my original function. I can solve for my c's. The second problem, I put it in a context. So we're still starting with the second derivative, but it's the acceleration of some particle. So I have the acceleration at some time t will equal cosine t plus sine t. So this particle's doing all kinds of things here. So what if I was asked the position at t seconds? In other words, find the position equation with t's. So I also gave you some initial information, the initial velocity. At time 0, the velocity was 5 meters per second. and the initial displacement. At time 0, the position was 0 meters. So if I'm going to get to position and I'm starting with acceleration, I'm going to have to take the antiderivative twice. So I'm going to start with v of t, the antiderivative of cosine t plus sine t. So I know that the derivative of sine gave me cosine, and it's positive. The derivative of sine was a positive cosine, so working backwards, I know this will be a positive sine t. Now, this sine came from taking a derivative of cosine, and the derivative of cosine is negative sine. I don't have a negative on here, so I need to put a negative cosine t and put my plus c. So the kinder, gentler version than this one is that they actually gave me, or I gave me, an initial velocity of 5. So that lets me solve for the c right now. So I'm going to plug in 0 for t and 5 for the velocity. So 5 equals sine of 0 minus cosine of 0 plus c. I know that sine of 0 is just 0. Cosine of 0 is 1, so minus 1 plus c, and that tells me that c equals 6. So I can rewrite my velocity equation as sine t minus cosine t plus 6. Okay, to get to my position, I have to do the whole process again. So I'm going to take the antiderivative of the velocity. So the position, s of t, will be the integral of this. So sine came from cosine. So I know the derivative of cosine t is negative sine t. There's not a negative, so I'm going to put a negative on my cosine t. The derivative of cosine, and having a cosine derivative came from sine, and its sine goes straight to cosine, so this negative stays on. Leave this as a sine t. Take the antiderivative of 6, I get plus 6t plus another c. And you might take the derivatives just to make sure you're getting the right thing. So the derivative of cosine is negative sine times the negative is positive sine. The derivative of sine is just normal cosine times the negative cosine t. The derivative of 6t is 6. The derivative of a constant is 0, so everything worked out. So now I'm going to plug this point in. S of 0 equals 0. So I'm going to put a 0 here, equals negative cosine of 0 minus sine of 0 plus 6 times 0 plus c. So 0 equals, and then cosine of 0 is 1, so negative 1. Sine of 0 is 0. 6 times 0 is 0 plus c. So I'm going to take this negative 1, move it to the other side, and that means that c is equal to 1. So now I can write my position equation. S of t will equal negative cosine t minus sine t plus 6t plus 1. And I did need two pieces of information because I started at the second derivative to get back to the original. For the first problem, I also needed two pieces of information.